What's up friends, today we have a brand new style of video for this channel. Today we're doing a one video build, and this is pretty cool because at the beginning of the video we start with the parts layout and at the end we have a functioning board. So I am in the middle of editing that right now, and I completely forgot to record an intro for this because I recorded over a bunch of different sessions of building with my friend. So today we're going to be building the board that we called Squeeze. Alrighty, so we're just going to jump straight into this with a parts spread, and you're probably going to see this footage a couple times while I explain what we've got. So starting from the top, we have got a Eovan GTS Super carbon deck, and this is sort of the base plate for this whole build because my friend won this deck at an SD Skate event, and it kind of just sat around for a long time until we built it. So we finally got around to building it, and this is the build that came out of it. In this short time lapse, we're actually putting together the trucks. These are limited edition Boardnamics 180mm trucks with red hangers. They are on the standard base plates, and I believe we picked a 45 front, 33 rear for this one. We're also assembling the pulleys. These are 40-tooth Boardnamics metal pulleys that will interface with the wheels, which you just saw there, that are Mad E-Skate 105s, which he also won at an SD E-Skate event. Now, our next step here after assembling the trucks and getting the wheels on was to encounter a huge issue, and that was the fact that these hangers and base plates did not fit in the deck. And this was a huge pain because it meant that we had to grind off a bunch of the corners of these base plates in order to fit in the deck, and that was modifying both the base plates and a little bit of the deck. So you can see me and him filing out the corners and grinding off the corners. It took a long time and it was a huge pain, but the end result did sort of pay off. We did run into some issues with the height of this deck though later, which I will explain when we get there. Next up was the battery build, and for this particular board we had a cheaper battery made of the Lishen 2170 LA cells, and these are a 4000 milliamp hour cell that is pretty similar to Samsung 40T, and so we are doing a 12S 4P of those, and of course making sure to cover them all in Fishpaper. This is really important for this deck because you've got a battery enclosed in a full carbon fiber enclosure and deck, and then you're standing right on top of it. So it's really important to get those in there. And there was barely enough room in there for the Fishpaper, so I really wonder what the company did in their own battery builds with this limited space. Looking at our battery construction, we've got pre-cut pieces of 4P nickel strip, and those are spot welded to the positive and negative ends, of course, of each cell group. And then we're going to go ahead and use copper braid that goes from the series group to the next series group. So we went ahead and pre-tinned all of the nickel strips, of course being careful to not put too much heat into the cells, and this ultimately helps you get a much better connection with your braid with a lot less heat transferred into the pack. Along with pre-tinning, we do actually use some fiberglass here to help insulate the pack from the heat of the soldering iron, and then you kind of go ahead and melt the strips or the braid into those solder joints. We did use flux on this braid to help get a better connection, and that's definitely an essential thing to have on hand. You don't want to use too much flux though, or it can wick the solder all the way into those joints. On the positive side, if you do manage to wick the solder in too far on this particular build, it's not as big of a deal as it is on a flexible build because there's not really any flex to this deck at all. Our next step was to attach the positive and negative to the pack before we did our final soldering of the braids. So we went ahead and attached the positive and negative discharge wires, and this is going to be a pretty low amperage build. Realistically, these cells are only good for about 10 amps to 12 amps each, So this is really a 40 amp discharge pack, which is not very powerful, but this was sort of a budget build that we were going for. And while I don't have a budget summary, the total price is definitely low. These cells are pretty dang cheap, and a lot of the components were won or purchased secondhand. So the attachment of these positive and negative discharge to the nickel is something that I usually do before I weld the nickel to the batteries, but in this case we ended up doing it afterwards, mostly because I forgot about attaching the leads. And it doesn't really matter that much because these are just 12 gauge wires, and we're not really putting much heat into the cells themselves. If you go ahead and touch the nickel nearby after soldering this, it's barely even hot, so really not a big deal. The reason we went 12 gauge for the discharge is because, again, literally 40 amps of discharge, and it's on a lower powered MakerX ESC, so we went with an XT60 and just a lower gauge wire to make it easier to solder. So here we're attaching the XT60. Of course, we're using a legitimate Amass XT60. If we do end up going a little bit higher in amperage, it will help out to have that legitimate connector to make sure we don't over stress it. So here we're just soldering that on, and then we'll move on to the next step. Moving into the next part of this build, we're obviously going to be wiring up the BMS. It's pretty simple for this battery. Everything's right on top and all of the series connections are easily accessible. As always, all the connections are on the negative side of each cell, and the cables are run down the center of the pack. We aren't taping them down yet, but they should clear the lid and shouldn't go above the battery level.
All right, so we're here on the final stages of the battery for this build. The soldering for all the balance wires has been completed, and we checked the connectors to make sure that they were all in the correct spot, and they are. So now we have positive here, negative there. We have a lot of finishing touches to do on the battery, but right now we're working on the BMS. So here we've got the LLT 17S, well, 10 to 17S, and the C- connector is going to this XT30, which is connected to a fuse on the positive side, and this positive is going to be going to the battery positive here. And then on the negative side, we are going to the connector itself, which then goes straight into the charge port. So we have a fused charge port, we have a disconnectable charge port, which, trust me, is always much better than not having disconnectable. Now the only cable left to connect here on the BMS is B-, which just goes straight onto the negative on the pack. So we've just got like 2 steps of soldering left to get the BMS connected, and then the battery will be capable of charging. And as soon as we've got the B- and the C and the charge plus connected, we can connect up these wires. So yep, that's all for this step, and then we'll move on to wiring up the ESC and wiring up the anti-spark switch, which I also am currently working on over here with my crimp tools, and try to figure out how to use my new smaller switch that actually fits in the enclosure instead of the gigantic one that is provided with the anti-spark. So check back in a minute.
Alright, so this is a point of the build where I kind of ran into an issue that took a long time to solve. So if you noticed, I said that I was trying to figure out how the switch was working and if I was going to be able to get a replacement. Well, I bought some replacements on AliExpress, waited for them to deliver, and they came, and unfortunately they weren't the right spec exactly. Basically, the FlipSky Anti-Spark uses a 5-pin switch with a normally open and a normally closed pin, and it uses both of those pins to turn on and off the anti-spark switch. Basically, you can use only one pin to turn it on, but it needs the activation of the other pin to turn it off just because of the way that it's wired. So basically, I had to find a 5-pin switch that was short enough and the right diameter to fit inside of the small amount of space inside of this skinny little deck. Now, you might think this is kind of an easy task, but I spent a lot of time searching on AliExpress and I just couldn't find one that was the right size and the right amount of pins. I found ones that were 4 pins that were that small, and I tried wiring a 4-pin one up to this and it didn't work. There might be a way, but I did a lot of research and couldn't figure it out. So what I ended up doing was I had to hit up my friend who is very skilled in Taobao searching, and he was able to find the right 5-pin switch in the right depth to make it work on this board. And man, that is a lifesaver, because otherwise we probably would have had to switch ESCs to the DV4S and then use a switch in that instead of using the anti-spark. And we wanted to use the anti-spark because my friend won that anti-spark in a giveaway. So, oh man, it was a process to try and figure that out, but after some good amount of time spent on it, I was able to find the correct switch through my friend and ordered that, got it installed, wired it up the same as before, and all's good except for the fact that it was only a 12-volt LED, and for some reason the anti-spark runs full board voltage to the LED, so the LED blew instantly. So now when you turn it on and off, you don't actually see a light. So it's a little bit hard to tell when the board is on, but yeah, is what it is. And maybe if my friend spent a little longer looking, or if I asked him to look again, he could find one that uses a 48 volt or a 100 volt LED instead, but it's not that big of a deal, and it's kind of just a thing that you have to remember. So anyway, that part finally got all figured out, and after that was wired up, I was able to move on to the next step. After we finished soldering up the battery and connecting all the wires, we went to try and figure out a solution on how to insulate it a little bit better. There was not going to be room for heat shrink, trust me, there isn't. So we went with Kapton tape to at least keep the bits of metal covered, and that was mostly for us. To actually protect the battery against the deck, we ended up going with Fishpaper on top, and we did end up gluing down all those balance wires. We checked a couple times here with the lid of the deck to make sure that the battery wasn't going to be contacting it, and it in fact didn't, so that was good. In this step, we're going ahead and putting silicone on the battery, and the main reasoning for this was because there was literally no room for adhesive or hot glue underneath the battery, so we went ahead and used silicone on the sides to help keep it in. And while this is obviously going to sort of put it in there permanently, didn't really want to open this up after we put it in here. Another huge ordeal that we had at the back here was that the hole for the cables was really not designed for this many cables to go through. It was designed for 2 small cables from the stock motors that have like the combined phase wires and sensors in there. So we went ahead and put in all of the VESC sized wires and then gooped a bunch of silicone in there and taped it down with Kapton tape to kind of squish it all into place. And you can see how it looks when it's all in here. It does fit, but it's very tight and it's all squished down. At this point, all the essential steps of this build are done. The battery's installed, the motors, which are they're 6355 motors from Boardnamics, are installed. The belts are installed. The DV4 is installed. We swapped the connectors on the motor to be the larger bullets to be compatible with the DV4. We got the VX4 controller receiver in there, and we've also got the charge port, which is a regular barrel plug. All right, so right there you saw what was basically the last step to getting this board on the road. Now, there will not be any VESC programming tutorial for this board or anything like that. Basically, settings that I went with were 20 battery amps per side, totaling up to 40 for the Lishen cells, 60 motor amps per side. I don't know if it can hit that or not. We don't have a data logger connected right now. And using the VX4 in UART mode. And I think I put a little bit of a throttle curve on it to make it more responsive. One thing I will say, I ran into a huge issue with the VX4 and the DV4S on here, and it was kind of my fault, but also kind of not. So basically, if you ever have this happen, you're configuring a board, you flash the firmware to a different version, UART remote just won't work at all. Basically what you have to do is you have to go into the control mode in VESC remote and make sure this is set to current, or whichever one you want, on both sides of the ESC separately. And then your UART remote will work. It took me forever to figure out that problem, and it wasted a lot of time. So if you ever run across that problem, check that first. VESC remote, control mode. Now, the other thing is that the DV4S that we've got in here right now, it actually has a dead UART port, which is really weird. I think that's pretty rare. We're gonna send it back and have it repaired by MakerX. But yeah, so originally we were gonna have a Meter Pro in here for data logging and then the VX4 on the other UART port. But for whatever reason, that UART port is actually dead, so we can't use that one. And that's unfortunate because it's really good to see all the data readouts on the VX4, especially with the new firmware. If I go ahead and power it on real quick. So on the new VX4 firmware, the 1.21, let's switch to manual here. You can see that there are a whole bunch of data readouts, which is really great. You got motor temp, ESC temp, voltages, how fast you're going, trip distance, etc., etc. And all of that is super fun to have on there, and really good to see the battery percentage and voltage on there, because right now there's no battery readout on here. So it's very important to have that as a point of data. Now, this board has been on its first ride, only its first ride. We went about 7.8 miles or so, ended with like 30% left, and we started riding at about, I want to say 60%. So I think this will probably have around 16 to 20 mile range. We're gonna have to do an actual test to figure that out, but here's a couple things that I observed. So I'm gonna pick this up real quick. This board is fairly light. It's not like a light board, but it's much lighter than the other board that my friend rides, and it's also much lower profile and rides really close to the ground. I'm gonna try to get this in a position where you can see here, or I'll put B-roll. You can kind of tell that these motors are very close to the ground. Now, the reason they're in this position is because I'm pretty sure the next position up, they'll hit the deck when you turn, but that is to be seen. And because they're so low to the ground, they got quite scraped up. Gonna be pretty hard to see on here. I'll put some B-roll instead, but they were scraping on like every single bump that you could possibly have on the ground. So that's one thing that we're gonna have to troubleshoot and figure out what's going on there, if we can put them up one notch and maybe get a little bit better ground clearance. Of course, slightly bigger wheels would give better ground clearance as well, but we don't want to change the pulley ratio, and you know, it gets a little bit complicated once you delve into that. So, but despite that, the board rides beautifully. It's got super smooth acceleration. It has an okay amount of power. It's definitely on the more average side of DIY builds. It'll still go over 30 miles an hour, but it's going to take a little bit longer to get there than some of my other boards, and we'll make sure to get a P-spec score on this before doing, I guess I'll do like a summary video of this board and do the P-spec and see what it all comes out to. These drop-through trucks with the bushing setup on here right now, we've got 93A barrel on board side and then 87A barrel on road side, and it feels really, really nice. It has really good turning radius, even with the drop through, and it feels pretty stable. And These red Boardnamics hangers look awesome on here and really just bring the whole build together with the red deck, red handle, and kind of that red and black theme. Mad wheels, great as always. Pulley ratio is fine. Like I said, it's kind of a more average performance board, not anything like a race board or something like that. But overall, first ride was really fun, and my friend says that he doesn't want to ride it like this because of how much the motor scraped. I would probably ride it for a while, but they definitely got pretty beat up on this first ride compared to some other boards that I've made. So yeah, this was definitely a challenge, from having to grind the base plates out to make them fit in the deck, to how tight the battery is in there, to the ESC having issues. But overall, if you don't have any of those issues, this is a pretty fun build to do. And honestly, having a built-in deck like this, there's just something cool about having your whole board just in this thin chassis and just having no wires outside except for the motor cables. And even at that, since we used the actual cable channels that came with the board, the cables go straight in front of the base plate. And you'll see, if you recall on that B-roll of us filling that channel with silicone, that area is pretty well sealed off now. And one of the goals of this board was to be able to ride it in slightly damp conditions. Obviously the Mad wheels may slip a little bit in wet weather, but the point was to be able to ride it from one short location to another after maybe it had rained. So I think we'll easily be able to achieve that as long as we put a little bit extra water resistance around the edges of this kind of board lid. It does have a gasket in there, but to be honest, I don't really trust it 100%. But other than that, there's not really anywhere else for water to get in. So I guess I've been talking for a while now, but I've not done one of these video builds before, so I just wanted to make sure I gave you guys all the details that I normally give in a more detailed build video, because the rest of this will all be voiceover. But yeah, summary: board rides awesome, super smooth, semi-low powered, turning radius is good, really nice and maneuverable, fun to carve. VX4 is working fine through this carbon fiber enclosure. I know some people have problems with that remote, but we're gonna kind of play it by ear, see how it works out. The data on it is great. Range for this board, don't know yet, but I think it'll be fairly decent, especially with the Mad wheels and the lower power settings. So yeah, overall, I'm really happy with this product, and it looks really pretty. And it's definitely one of those nice polished builds that people might not be able to tell that it's a DIY. So hopefully you guys really enjoyed this one build series, and one video build. And let me know down below in the comment section if you want to see more of these one video builds. I know I typically do series and like to kind of give you guys a look into every part of the building process, but if you like videos like this, make sure to let me know down below, and I'll consider doing some more of those, especially for boards that I have to rebuild. So yeah, let me know what you think of this build, and thanks for watching. Stay safe, keep on riding, and peace out.